Hello everybody, we're going to be talking about graphing rational functions today. We need to first discuss a few items that are going to be of importance. The first thing is vertical asymptotes. To find your vertical asymptotes, those are going to be the places where your function is undefined. And so to find those places where your function is undefined, we need to find, look at the bottom, or rather your denominator. And set it equal to 0. Okay, we'll talk a little bit about how holes come into play a little later, but for the most part right now, take your denominator, set it equal to 0. Those are going to result in vertical asymptotes. Horizontal asymptotes you should have talked about in Algebra 2, and with horizontal asymptotes you want to look at the degree in your numerator versus the degree in your denominator. If the degree in your numerator is greater than the degree in your denominator, then you have no horizontal asymptotes. If the numerator in your if your numerator degree is less than your denominator degree, then your horizontal asymptote is always y equals 0. And if the numerator degree is equal to the denominator degree, then your horizontal asymptote is y equals the ratio of your leading coefficients. Okay. Another thing that's going to help us graph rational functions is to look at the x-intercept. If you remember, x-intercepts are found when you put 0 in for y and you solve for x. And then obviously your y-intercept is when you put 0 in for x and you then solve for y. So let's take some examples here. Let's look at this example, y equals 3x plus 5 divided by x plus 2. And let's just kind of graph this rational function. The first thing that's going to help us is to find our vertical asymptotes. So I'm going to take this x plus 2, my denominator, I'm going to set it equal to 0 and solve it. So I will have x equals negative 2, and that's going to result in a vertical asymptote. The horizontal asymptote, remember, is found by looking at the power in the top and the power in the bottom. Well, my power in the top is an x to the first. The bottom is an x to the first as well. So when I take those coefficients, 3x divided by x to the first, those x's essentially are going to cancel, and so I'm left with 3. So that's why I have y equals 3 as my horizontal asymptote. Let's look at our x-intercepts. The x-intercept is what I get when I put 0 in for y. So I'm going to say 0 is equal to 3x plus 5 all divided by x plus 2. So when I solve that, I'm going to multiply my x plus 2 to the other side. And so that will be 0 is equal to 3x plus 5. And when I solve that, I'll subtract my 5 over, divide by 3 off, and so I will have negative 5/3 as my x-intercept. And then my y-intercept is what I will get when I put 0 in for all of my x's. So I have y is equal to 3 times 0 plus 5 all over 0 plus 2. My 3 and 0 will cancel. My 0 here is gone. And so I have positive 5/2 as my y-intercept. So let's go to a graph now. And let's just put this information on this coordinate plane that we've created. I have a vertical intercept, or I'm sorry, a vertical asymptote at negative 2. So through here on negative 2, I'm just going to put a vertical line to show that my graph is going to basically kind of hug that asymptote. Then I have a horizontal asymptote at y equals 3. So I'm going to go up to 3 and put a horizontal dashed line through y equals 3. So we've kind of given ourselves parameters of how this is going to be, how this graph is going to appear. Let's put our x-intercepts on. Our x-intercept is negative 5/3. So that's about negative 1 2/3. And so that's going to be right about, I'm going to graph this in a different color. Let's just graph it in white, I guess. So negative 1 and 2/3 is going to be right about there. Okay. And then my y-intercept is going to be at positive 5/2, so that's about 2.5. So right about there. At this point, I will allow you to go ahead and go to your calculator and see what's going on around the rest of this graph. What we also could do is make a table of values of some x's and y's. And let's just see what's going on either side. So if I would pick maybe on either side of my vertical asymptote, let's maybe pick -3. Let's pick -4. And then on the other side, how about -1, 0, and 1? And let's just put those points back into my original function and see what's going on with them. So if I put -3 back in, I'll have 3 times -3 is -9 plus 5 is -4 divided by, and then when I put -3 in my denominator, I'll have -1, so I have a positive 4. So I need to graph this point to be -3, positive 4. Okay. Let's see what's going on at -4. So 3 times -4 is -12, plus 5 is -7, and then -4 plus 2 is -2, and so that's going to be 7/2, which is 3.5. So at -4, I'm going up to 3.5, right about there. So I'm seeing this kind of hug those asymptotes, and you can see that this is going to continue to get closer and closer to that vertical asymptote and never touch it, never hop over it. It's going to stay there. Now, let's look and see what's going on -1, 0, and 1. If I put -1 in, I'll have -3 plus 5 is going to be 2, and then -1 on my bottom is going to give me a positive 1. I get a 2 here. So we have -1, 2 is right there. And then 0, we obviously realized already that 0 is going to be, we graphed that, so I guess we didn't even need to graph him. And then when I put 1 in, that will be 3 plus 5, which is 8, and then 1 plus 2 is 3. 8/3 is about 2 1/3. So at 1, I'm going up to about 2 2 2/3, which is right about there. And so this graph is going to hug this direction. Okay, so you can see the horizontal asymptote is telling you what's going on as we go farther and farther and farther out to the right and to the left, and the vertical asymptote is telling us what's happening as we go up or down.